this. Okay, done. All right, I think some of you are just waiting for me to just do it for you. So why don't we go ahead and do this together now that you've had a chance to at least read it over. And you might have been able to do part of it, maybe all of it, because like I said, it's exactly like what we've been doing in the past. There's the big difference is that we're dealing with dependent samples. And so there might have been like a confusion over where do you get this average difference? Well, you compute the differences and you take the average of the differences, of course. But let's go ahead. We'll work through this. It says, let's see, we're looking for a claim. Here it is, right in the first sentence, claims that training on the balance beam reduces reading errors among learning disabled youngsters. So what is the claim? The claim is that after we do the balance training, you'll have fewer errors than before. How are we going to write that though? We're going to write it something like this, that the difference between after and before, average difference, is going to be less than 0. So we might want to specify though that the difference that we're talking about here is after minus before. I believe on Newton, if you had done that assignment that I was assigning, at least in my head I did. I don't know. I'll fix it though. I'll put it on there. I don't know when. I don't want to overload you over break. But um, you'll get a chance to do it. And when you do it, it will be clear because Newton, in their problems, they're like, you're going to do this difference. This is the difference we're interested in. After minus before. So if you thought of this in terms of before minus after, of course, you would think that the difference would be positive, not negative. So, but we're going to go with this because this is the way that these numbers have been computed. So null and alternative hypotheses, you know the deal here. You can do this. The null hypothesis is mu sub d is either equal to 0, or if you really want to be fancy, you can put it greater than or equal to 0. I don't care. Alternative hypothesis, mu sub d is less than 0. Two-tailed, left-tailed, or right-tailed, that thing is left-tailed because of that symbol. It's always the alternative hypothesis that tells you. So look at that. So good practice for all of our hypothesis tests. Next, we're going to compute the average difference. So this, I was mean, I didn't put it in here, but this here is just our hypothesis test gold spreadsheet that the one with the single mean. So when you do this eventually on Newton, you're going to have to look up your, use your hypothesis test gold spreadsheet for single mean. And the way you're going to do this is you do after minus before. We need an additional column here in our little chart. So after minus before is going to go here. I'll make these numbers. And this is a little annoying that they're all negative, well, except for that one. But if you made them all positive, then the problem would be that you would be getting the opposite of what we were doing here. But I think you can still figure it out. Okay, so average these together. I added these up and I got negative 13 divided by 9 gave me, divided by 9 is negative 1.44. So the average difference between after and before, after minus before for all of these kids is negative 1.44, meaning that they, on average, had 1.44 fewer errors after the balanced beam training than before. Okay, I guess I should have also had questions about p-values and the test statistic. Here's the test statistic up here. The p-value, because this is a left-tailed test, is right there. Oh, is there a problem? I hear people singing. I'm just kidding. There was moaning. Was that moaning in the back? No moaning? Or you just don't like my answers? Okay, yeah, you can complain. It's fine. Just let me know. Okay, but anyway, let's get the decision and the conclusion, and then we'll come back and see what sort of complaints you guys have. The decision is you're going to reject the null hypothesis, and actually let me know what you're rejecting. You know the joke. If you just say reject, I don't know what you're rejecting. And then the conclusion is that there is evidence to suggest that balance training reduces errors. Reduces, what kind of errors? Oh, reading errors. Okay, reading errors. There, good enough. Something like that. It's heating up in here for some reason. Whew. Whew. All right. All right, so does that look good? So what sort of issues do you have? Questions, concerns, complaints, anything like that? You can do this probably without even doing homework, but so hopefully you probably just gotten 100%. But even if you didn't, you fixed it, right? You know what's going on? So no complaints? All right, so no complaints. So when it comes time to do this on Newton, whenever I finally figure out when to put it, because I don't want to overload you over the weekend, we'll figure it out. And on the test, there will be one like this on the final. Okay, moving on. Fun, well, for me, I like this particular lesson. There are two lessons I really like. One of them is correlation. One of them is chi-squared. So hopefully we'll get to chi-squared because we only have a week left. So I gotta pick and choose. So chi-squared, I think, will be one of them. But correlation, this is kind of fun because we know what correlation is. At least you probably heard the word. Correlation. What does the word correlation mean? Correlation is just a word that means joint association. Two things are correlated if they're associated in some way. So something is associated with something else. You probably know examples of this, and I will show you some examples. Let's see, I've got some examples here. Why are they so far into my thing? I don't know where they went. Maybe I don't have them. But, well, I can, oh yeah, here they are. Sorry, I went too far. Anyway, correlation, though, is not causation. So if you ever take a psychology course, you probably have heard this phrase before, correlation is not causation. They love that in psychology, or they love to say that, because we oftentimes find correlations between things people do and different things, and it's not a causal relationship, though. There is not a causal relationship. Correlation does not mean that one thing causes the other or vice versa. It just means there's a relationship, an association between the two things. For example, to talk about causation, if two things are correlated, if you have A and B correlated, for example, your height is correlated with your shoe size. Your shoe size and height, they're related. If you're really tall, you probably have big feet. If you're really short, you probably have short feet. So you probably are familiar with this phenomenon. Anyway, those two things are correlated, but is your height causing your shoe size, or is your shoe size causing your height? Well, here's the deal. If two things are correlated, then one of the following is true. Either A causes B, that is, height causes your shoe size, or it could be that B causes A, that your shoe size is causing your height. But there's a third option, and that third option is that there's something else that causes both A and B to either go up or down, and it's not one of them causing the other or vice versa. It's that there's this third thing that's causing both of A and B that we don't know about. So all we know is that A and B are correlated. In the case of your shoe size and your height, it is not your height that is causing your shoe size or vice versa. It is your genetics that cause both to be bigger. So it's genetic, it's your genetic makeup that causes bones to grow longer or shorter, and so your foot bones will grow longer proportionate to your leg bones, and so on. So there is something else that causes A and B. There's this fable that I like to tell about this idea of causation, that there was this empire long ago where the emperor discovered a correlation that he was not happy about. He found that there were cities where there was disease, lots of disease. People were dying from disease in these cities here and over there. And he discovered that in the cities with the most disease, there were also the most doctors. So he concluded that the doctors were causing the disease and had them all executed. Now, obviously, that's ridiculous, that it was in fact not the doctors causing the disease, but opposite, that the disease was probably causing the doctors to go where the disease was, to help the people, because that's what doctors do. So this is, I guess, trying to point out the danger in trying to think that one thing causes another because we have a correlation. So correlation is not causation. So what are some examples of correlation? First of all, correlation coefficient. We need to have quantitative data. We have to have quantitative data, things that we can measure with numbers, like your height, like your shoe size. Those are numbers. So we're going to have numbers, so you'll have a pair of data. For example, you have your height and you have your shoe size. You could jot that down. We're going to use it in a bit, so you might as well. And here's what I'd like you to do, and I know that this is very, US-centric of me, but I'm going to ask you to write down for yourself. So you have your height, and so you can write it down in inches, not centimeters. If you don't know the conversion, just do your best, take a guess. And yeah, I'm going to write mine down. And then write down your shoe size, US shoe size. So your US shoe size, so write that down. So here's height, and then your shoe size. So just jot it down. But you have two numbers. So now everyone has two numbers in front of them. Those two numbers are your pair of data. So we can make a scatter plot of our data. If I were to gather up all, which I'm not going to do, don't worry. I will ask some of you for your numbers in just a bit, but not now. So if I were to gather them up, I can make a scatter plot. You know what a scatter plot is because all of you had 7th grade math where you put dots on a field of, like a grid. Here, I'll show you some scatter plots. This is a scatter plot of the grades that I got a couple of years ago. Actually, I dug back. I wanted a big class. I had a class of 45 back in 2019, so it's 5 years old, but whatever. It still is valid. And this is a scatter plot of the students' homework versus their final exam. I show this to you because I'm concerned about some of you having low homework scores. Notice that it's all scattered around, but there is a general trend, isn't there? That for people who have low homework scores, generally they have low exam scores. And then up here, the people that have hundreds on their, like if they did their homework, they have mostly high. No one flunked who did all their homework. So you have to drop down here to someone, or flunk the final. So here, this person got a 61 or something and did most of their homework. And then you start getting people down here. But there's a general trend, isn't there? You can sort of see this trend upward. That's what we're looking for when we're talking about ordered pairs and correlation. Now, this correlation coefficient, we're going to compute. I'll show you how to compute it momentarily. Before we do that, though, I have, let's see, some examples. Here we go. Let's do the examples. So these are examples of things, and what I did was I just searched various, actually used the library website to search scholarly articles that had the word correlation in them. So these are from all over, like different journals. So I found some education journals that said that there is a positive correlation between education and income. The more education you get, the higher your income. In general, that doesn't mean that there's not going to be some outlier like this person over here who did most of their homework and still did really poorly on the exam. There might be someone who has high education, like myself, with a low income, like myself. But it's because I choose to work at MPNU, where I feel like the surface that I do is more important than the income. But in general, if you get a PhD, your income will be much higher than if you get a high school degree. Height and weight. If you're tall, you're going to be heavier. It's just the way it is. Your bones are bigger. Height and weight. That came from a nursing journal. Age and net worth. Some finance journal. So yeah, the older you are, the more you have. This was true for me. Even though I don't have big income, I've been sucking away money all my life, trying to, so that I could retire at some point and go live with my grandchildren. But so age and net worth is that as we get older, we generally have more money. It's not always true. You always, like my brother, for example, has no money because he squandered all of his money. But and he's 53 or something. But in general, age and net worth. Sodium and blood pressure. That came from a nursing journal. If you eat more sodium, you have a higher blood pressure. And then there are some negative correlations. So negative means that as one of them goes up, the other one goes down. Education and years in jail. Once again, got this from an education journal. The more education you have, the less likely you're going to spend time in jail. Crying and being held. I have now 2 grandchildren, and this summer we discovered the truth of this, is that if we held the baby, this newborn, they would not cry. And if we put them down, this child needed to be held 24 hours a day, basically. But the more a child is held, the less they cry. And we're hoping that child, they're getting better. At least the reports I get from Boston are that this child is getting better with the crying. TV viewing and grades, once again, I got this from Education Journal. The more you watch TV, I guess nowadays it would be streaming, whatever, the lower your grades. There is a negative correlation. And then potassium and blood pressure, if you are worried about your blood pressure, eat bananas. Increase the potassium and blood pressure apparently goes down. Once again, got that from the same journal article that was. So these are just some correlations that you might be familiar with or maybe not, but at least it gives you an idea of what we're talking about when we talk about correlation. So let's go ahead and actually compute a correlation coefficient. So to do a correlation coefficient, what you do, so this is the way the correlation where it comes from, is you get a sample. We are a sample. And you compute z-scores for the 2 numbers. So I've got my 2 numbers. I wrote them down back here somewhere. Here, I'll put that back up there in a sec. So I've got my 2 numbers, and I take my numbers and I compute 2 z-scores. So I'll have a z-score for my height, and I have a z-score for my shoe size. In order to compute these, you're going to need to know the average and standard deviation for each of them. So here are males and females. And for female shoe sizes, it is US women's shoe sizing, not men's. So if you want to be super accurate, you could make sure you know your women's shoe size. And for men, it is the US men's shoe size. I got this information from the CDC website on, they have like averages for all sorts of things up there. So go ahead and compute your 2 z-scores and then multiply them together. I will do the same up here just so that you know what we're doing. If you're confused, I will compute my z-score for my height, and then I will compute my z-score for my shoe size. So if you're not sure how to compute z-score, this will remind you. And then this is going to be 13, 2, which is 2.5. Okay. So my z-scores are here. I've got 1.33 for my height So I'm a little above it, not a huge amount. I'm no, you know, Minute Ball or, you know, one of these tall, super tall people. Shaq, I don't know who the basketball players are these days. But anyway, um, but I'm a little taller, just a little taller than average, and my feet are a little bigger than average. 1.25 is my z-score for my shoe size. So there's my numbers. And then what I'm going to do is I'm going to multiply my z-scores together. Well, I can do that. 1.25 times 1.33. Give me a sec here. Is 1.66. So there's my product. So everyone else did this as well, hopefully. And I'm guessing that most of you have a positive number when you multiply your z-scores together. This is regardless of if you're tall or short, right? Because if you're short, below average, you'll have a negative z-score for your height. And because height and shoe size are related to one another, you'll probably also have a negative shoe size or negative z-score for your shoe size. So height and shoe size will both be negative or both be positive. By the way, and you don't have to answer. Did anyone get 2 negative numbers for their z-scores that wants to volunteer that? You don't have to. Okay, so you can imagine though, you can imagine someone who is shorter than average, a little below average, gets a negative z-score here, and has a short, foot, and so negative z-score here. But if you have 2 negatives, multiply them together, you get a positive down here, don't you? What about anyone who has a negative for the product? Does anyone that wants? Oh, you've got one. Excellent, Cooper. Cooper, are you tall or are your feet really big? You have small feet. Okay, so Cooper is taller than average, but has shorter feet than average. So he's got these dainty little feet with his tall body, and when he multiplies a positive with a negative, he gets a negative number. So some of you, there might be someone here who is the opposite, who's a short person with big feet, in which case their product will be negative as well. But in general, most of us are going to get a positive number here. So when we average together, if we take all of our numbers, so if I took mine and Cooper's and everyone else's here and average them together, what I would get is I would get probably a positive number, and that will be what's called the correlation coefficient. So the correlation coefficient, don't write these down. Just trust me, you don't want to write those down. I'll let you know when to write. But correlation coefficient is literally just the average of all of those numbers that I suggested we compute. So if we average together the products of our z-scores for 2 measurements, average them together, that's all this is. It's an average. We get what's called the correlation coefficient. One of the interesting facts about the correlation coefficient is because we're dealing with averages, z-scores, and so forth, the correlation coefficient will never be bigger than 1. It will, we'll get to the easier way in a minute. Correlation is always between 1 and negative 1. Never bigger than 1, never less than negative 1. Always between 1 and negative 1. So an easier way, we'll talk about how to interpret this. So this is the easier way. I should put easier in quotes. Don't write that one down either. So this is easier in the sense that back in the olden days, 15 years ago, I made students do this on a hand calculator. And it was fine, we did it. So what this is it's the average of the product. So if you multiply your shoe size by your height, and then we averaged all those numbers together, and then we average all the heights together, and average all the shoe sizes together and multiply those, subtract, and then this is just a weird product of standard deviations. But anyway, if you did that, that would give us the same result. So these are equivalent, but then an even easier way, this is the way that we're going to do it in just a moment, is we're just going to use Excel. And there is a nice built-in feature called Corel. If you do have your laptops and want to follow along, we'll be using them later, but you don't have to because today is kind of Excel light. We'll use it a little bit. So Corel is the function that you use to compute the correlation coefficient. Before we go on, we have some statistics you can use. Well, it's not so much statistics you can use. It's just this fascinating statistic that I happened upon in a paper about 15 years ago, 12 years ago. It was during the first Ukraine conflict, not the current one. But if you remember when you guys were in elementary school, Russia invaded Ukraine and stole the Crimean Peninsula, or there was some conflict down there. I don't remember the details because it's 15 years ago. But anyway, during that conflict, there was a group of researchers asked a sample of people to identify the location of Ukraine on a map. I'm going to show you the map they used. Here it is. So notice that it just has outlines. So can you find Ukraine on this map? Go ahead and take a guess. I'll show you where it is in a minute. So they asked people two questions. They first of all said, take this mouse. They had a computer. They said, click where you think Ukraine is. So you figure it out. Click on the map where you think Ukraine is. And then the second question was, on a scale of 1 to 10, how much do you think that the United States should get involved militarily in this conflict? So you understand the two questions. Number one, where is Ukraine? Number two, how much do you feel like we should get involved? Okay, so let's first of all show you where Ukraine. Everyone's got their answer, right? You figured out where Ukraine is? You got it locked in? Okay, here it is. So there's Ukraine. It would have helped probably if the water was colored blue, because this is the Black Sea and there is the Crimean Peninsula. But anyway, there's Ukraine. Did you get it right? Maybe. I don't know. No one's rejoicing. Like usually everyone's like, yes! Okay, it's too early. But anyway, there's Ukraine. So where did you click in your mind? Well, let me show you where the 1,000 or so people who took this little survey, where they clicked. I know. Is Ukraine in Alaska? So some people thought Ukraine was in Kansas, for example. Now, to their defense, there might be a small town in Nebraska named Ukraine, Nebraska. I don't know. But I mean, that would be interesting. But certainly Ukraine is not down here, or there. So there's where everyone clicked. Now, here's the interesting thing, is that when the researchers asked the question, how much do you feel like we should go to war over Ukraine? Here's the results. It turns out that our respondents thought that Ukraine was from, let's see, how far, the further our respondents thought Ukraine was from its actual location, the more they wanted to go to war, have the U.S. intervene militarily. In other words, the more stupid you are, the more likely you are to want to go to war. So even controlling for demographics, blah, 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 blah. And then down here, all of these effects are statistically significant at a 95% confidence level. In other words, 5%. So they were using alpha equals 5%. So I found that to be interesting. So I don't have the reference here for some reason in my PowerPoint, but I can find it if you really want to look at the original paper. Okay, quick intermission. And of course, surveys are this week. You might have gotten an email and you can access them, and we're looking for 100% compliance, or not compliance, submitting. I really, you can put whatever numbers you want. You can put comments. I like the comments better than the numbers. It's kind of fun to see people's comments and see what they think. Sometimes I get comments that are bizarre, but whatever, give me some comments, but take a couple of minutes, not now, but later, to do your end of course survey during the next couple of weeks. It will close. The survey closes on the Sunday before finals. So you've got 2 weeks to do this. You can do it. Now, if you're not sure what the answers are, let me just help you. So there's the correct answer, at least for me. So anyway, you can answer like that if you want, or not. But let's move on to this. So on our website, you will find linear regression. This is only if you want to follow along. You don't really have to in this class, but I'll show you what you'll be seeing. You'll be seeing this. This is the linear regression Excel spreadsheet, so that you can follow along if you want to using Excel. There's just a few things that we're going to do with Excel today, so it's not as important. We're not going to be making a new hypothesis test gold spreadsheet or anything like that. Okay, so let me go back here. So it's on Moodle. It's down below. You'll see like the bunch of stuff, and it's at the bottom of the one called linear regression. If you can't find it when it comes time to use it, let me know and I'll do my best. So to calculate R, we're going to use correlation coefficient, COREL, on the web, on the Excel, and I don't see here the spreadsheet that I was looking, or the picture I was looking for. So we'll just go and do this here with this. So what I have here is a fictitious, try to find my mouse. Why is my mouse not showing up? Oh, weird. It's like blank, invisible mouse. Well, it's right there now. Okay, well, I have here a fictitious study that I did. So fake data, but you know, it's okay. So movies and math. And what we have here is the number of movies a particular student watched during a given week, and then their score on a basic math quiz. And so once again, I've just sort of made up some numbers here, but here's how we're going to compute the correlation coefficient. To compute the correlation coefficient, type equals COREL, open parentheses, and then you have to highlight the first set of data. And you can include the numbers if you, or the letters, words if you want. You don't have to. I'm going to just to demonstrate that you can. But you need to make sure that when you highlight, that the two columns, you've highlighted the same number of numbers or the same number of cells. So anyway, there it is, COREL, C1 through C16, B1 through B16, and you can put those in either order, doesn't matter. Correlation doesn't matter either way. So notice I have a negative 0.96. So let me try to explain what that means. Negative 0.96 means, first of all, that there's a negative relationship. The more movies you watch, the lower your math score. Now, of course, I made these data up, and so I did this on purpose just to illustrate correlation. So, yeah, it's not true. I don't know. You could probably watch a lot of movies and still get a good grade in your math class. But anyway, so negative means as one increases, the other decreases. The second thing is the closer you are to 1, the closer things are to a straight line. Let me show you what I mean. We can make a scatter plot of these data. Once I find my mouse again. Why is it an invisible mouse? Come on, Cooper, help me out here. Okay, well, you can fix it later, I'm sure. Okay, so there it is. Highlight your data. Let's see if I can figure this out. Data, and then you go up to insert. There it is, insert, and you're going to insert a scatter plot, and we'll just pick the scatter plot right there. There's my beautiful scatter plot, and from the scatter plot you can see that there is a negative relationship. There it is, that the more movies you watch, the lower the grade, at least for these students, these fake students, that as the movies went up, the math score went down. Movies are along the bottom, math score is along the side. Okay, well, that's not too bad. So you can all do that. So COREL for the correlation coefficient, scatter plot for the scatter plot. Okay, so let's take a look at the next tab. Let's see what we have here. Example 2. Man, it's really annoying, this mouse situation. Oh, this one's boring. That's all fake data. Like it doesn't even have anything attached to it. This is real data. So this one I can explain to you, tell you what it's about. So these data, what I did was I looked on Amazon about a decade ago now. It's when I generated this. I should probably update this, but it's, I don't know, these data are, it illustrates something really nicely. Anyway, so these data, what they are is on Amazon, I searched for television. And then I scrolled through, and the very first little tiny television I got, which was a 9-inch television, I wrote down the price. And then I got to the next one that was a little bit bigger, 15 inches, and so on. So I just got a sample of some different sizes. I just decided, okay, I'll just keep scrolling till I find one that's bigger than 75 inches. And there was an 82-inch television for $2,500. I know, it's so expensive back then. You can get one for under 1,000 now, I'm sure. But anyway, so this is back about a decade ago, and these are the prices of these televisions. I want to know, is there a relationship between screen size and television price? And I think you can probably guess there is, but let's go ahead and compute this. Equals Corel, and then, you know what, I can just do this. The entire column A and the entire column B. You can use this trick. Notice that A colon A just means take the whole thing, and B colon B, the whole column. As long as you don't have any extra stuff down here, you can do this. But anyway, there's my correlation coefficient. Oh, positive. So I guess that the bigger your screen size, the more expensive makes sense, doesn't it? But here's the interesting thing about this one, that when you graph these, oh, come on, there it is. Just try to use my, whoa, wrong. Use my keyboard as much as possible here. So let's see, insert, let's go over here, there, that's what I want to insert. Up. Okay, yeah. Now notice this, that when you actually graph these data, it doesn't look like there is a relationship, isn't there? That as the screen size goes up, the price goes up, but the relationship doesn't look exactly like it's a straight line. It looks more like a curve, doesn't it? That it would be more appropriate to say that this was kind of a curve rather than a straight line. Now, we're not going to study this kind of relationship in here. We're just looking for linear, straight line relationships. But this has a name too. This is probably going to be either a polynomial or an exponential relationship. But that's for another class. So when you're in your advanced chemistry class and you're doing some sort of a regression, and Dr. O says, let's go ahead and do, polynomial regression, say, I need to know where to click, and he'll show you. So it's not that hard. It's pretty much the same place that we're about to click right now. Okay, so before we do that clicking though, let us look at some additional relationships just to see what these relationships mean. Come on, I thought I had some graphs. Oh yeah, I do. Okay, so it might be helpful to understand what different correlations mean. So these are correlations that are around 0.5. So this was a couple of years ago, exam 1 versus exam 3. Here's exam 1 versus exam 2. So those correlations, 0.58 and 0.54. So you can see that these are pretty scattered. There is a positive relationship, though, that is one increases, the other increases. By the way, one of the ways you can sort of think about positive relationship is think of like, imagine me with like a shotgun up here. I know there would be like SWAT teams or something, but just pretend like a paintball. I don't know. So I've got my shotgun and I'm aiming it up at an angle. What I get is, a bunch of little holes in the screen, and the buckshot would penetrate the screen in this scattered relationship. It wouldn't all be in a straight line, but it would be generally upward. If instead I was standing over here and shot the screen with my shotgun, it would create a set of dots, a pattern that went kind of up in this direction, like down and to the right instead of up and to the right. So that's the difference between positive and negative. Here's a few other relationships. Oh no, that's not a good one. Just a minute. Here, I like this one, but I don't think I have the correlation coefficient. This one, a couple years ago, the survey at the beginning that I gave you with the years, and I had you figure out when Taylor Swift, do you remember that one? When her 1989 album dropped? Anyway, a couple years ago, I accidentally had two questions that were nearly identical. Question one was, or one of the questions was, what year did Martin Luther King die? And another question was, in what year was Martin Luther King Jr. assassinated? So you understand, those are basically the same question. But my students didn't all think that it was the same question. But because they were so similar, I got a really nice tight relationship. This is very close to a 1 for correlation coefficient. So here's the correlation, or the scatter plot that I ended up with. So you can see that most of the students thought that Martin Luther King Jr. died in the same year that he was assassinated. So you have this nice, beautiful, straight line. So this is actually like a 0.95. It's very close to 1 because most of the dots, like some of these represent more than one person. So there's lots of duplicate dots here. So there's just a few people who didn't understand what the word assassinate means. Because there were a few people who thought that Martin Luther King Jr. Died in the year, say, 1905, but was assassinated some 30 years later in 1942. So I guess maybe they thought that assassinate meant like some sort of an honor that you give the person, like you're recognizing them, like sainthood sort of deal. I don't know. And then here's the other people, the other group of people I think are more understandable. Like this person here thought that Martin Luther King Jr. was assassinated in 1955, but ended up dying around 1960. That makes a little bit more sense to me because, he gets shot and then he lingers for a few years and then finally dies. So that one, I could understand that, the people below the line. But the people above, that's a little bit less understandable. But anyway, nice straight relationship. So the correlation here, correlation is very close to 1. It's like 0.95. By the way, that does not tell you the slope. Correlation of 0.95, it could be here. Here's a very close to 1 relationship. Could be this. Could be this. No, go back. Could be this. All of these are very close to 1 if you have dots that look like that. And then negative 1 could be like this, could be like this, anything. So the correlation coefficient doesn't tell you the slope. It just tells you whether you're going upward or downward. It doesn't tell you how steep that slope is. It just says there's a relationship. Okay, let's see. I needed to show you a couple more pictures. Here, this. Wait, not that one. That one's the one that we had. Just a minute. I thought I had that here. Here it is. Is that the same thing? Oh, yeah, that's not. Oh, I never computed the correlation. Okay, well, I'll tell you. I computed it earlier. This is for the homework and final exam for that class that I told you about from a couple, 5 years ago. And so this actually has a correlation coefficient of 0.667. So correlation is 0.667. And it's because, in general, you can see things are moving upward, but there's some, spread out a little bit. But in general, if you do poorly on the homework, you're going to do poorly on the final exam. And if you do like 40% of the homework, like this person, you're going to do, not that great, I guess. Here's someone that did 40% and actually passed the final, but they were kind of an anomaly. Most people will get about the same grade on the final as they do on their homework. By the way, you can do your homework late. It's totally legal and it's encouraged. So please do your homework, even if it's late. Get that homework grade up so that you can get a good grade on the final. Okay, so positive relationship. Now here's an interesting thing about this class. There is one student who didn't take the final exam this year. And I was kind of curious, what should they have gotten on the final if they had actually taken the final exam? They happen to have an 85 on their homework score. So an 85 on their homework score, what would you predict? What would you predict their final exam would have been if you imagine this person that has an 85? This is what statistics are used for. This is what a correlation and what we're doing, this linear regression. That's what it's used for. So the way we're going to answer this question is we're going to use what's called a linear regression equation. Now, you've got 2 assignments to do over break. I'm not going to add the third one, even though I should have had an exam or a homework for this. But the first one is due before the break because I didn't want to overload you. I thought, you got a few hours here today and tomorrow you could do this. And this one, the one that's due on Wednesday, is just like a review of lines, like y equals mx plus b. I know some of you are like, no. Okay, so you know this. So here, this is the slope, and this is the y-intercept. So you can deal with this. You know this, and so you'll see it's not that bad. But The linear regression, the actual linear regression equation, you need to use calculus to figure out the linear regression equation, but we're not going to. We're going to use Excel instead of calculus because it minimizes how far those darts are away from the line. I actually did it earlier today. Actually, this morning I did the linear regression equation for this, and here's what it looks like. That's the linear regression equation for the homework versus final exams. Using this, we could predict what that 85 on a homework, what would we predict that person would get on the final? And so here's how I would do it. Here we go up here, and it looks to me like that. I'm not using that dot. So I know that there's a blue dot right above the 85. I should have picked somewhere else. But I'm using the red line. That red line seems to predict that the person who got an 85 on their homework would get something like a 78 on the final exam. So, maybe I could just give them a 78 and, call it a day. In fact, why don't I do that for you? We could skip the final and I could just use this. Now, some of you are like, yes, actually, no, this isn't the greatest, is it? Yeah, because look, even if you get 100, you're only going to get an 85 according to this prediction. So the predictive value might not be that great for this, but that's what linear regression is used for. So, and I actually have that. Oh, and I guess I thought of a different person, my made up person. So no one missed the final that year. I just made up someone. I forgot that I'd made up a person. 79. 79 would have been better because look, 79. Let's erase all of this ink. Look at the 79. There is no one here who got a 79. So we have to rely on this dotted line to make our prediction. And how do we make the prediction? Well, we just plug it into this equation. So this equation, I'll show you how to get this equation. It's not difficult. The way you get this equation is we'll use Excel, but let's go ahead and make this prediction. 0.44 times 79 plus 40.925. That's going to be my prediction for what I think a person who gets a 79 on the homework would get on the final. 925. Okay, so that's a 75.68. 75.685. So that would be my prediction. So it'd be interesting for me to do this for all of you, make predictions, and see how close I am for your actual final exam. Now, because the correlation coefficient, so one of the things that about predictions, using the linear regression line to make predictions, is that the closer that correlation is to 1, the more likely you are to be correct in your prediction. We don't have time because for some reason we got behind this semester, but we don't have time to compute probabilities and confidence intervals, but you can compute confidence intervals for this. And because that's so low, 0.667 is not close to 1, it means that this is probably not all that accurate. Probably, if I were to make a prediction, I would make a confidence interval around this and say, I would predict someone would be between 60 and 89 or something like that would be my prediction. Okay, so let's see, how do we get this linear regression equation? So the linear regression equation, what you do is once you've made a scatter plot, you just right-click. Whoa, I'm on the wrong page. That's right, my mouse. So annoying. Find the mouse. There it is. There it is. Okay, right-click or double touch. I don't know how you do it on the Mac. But one of the dots and choose Add Trend Line. So I don't know if you can see it down there. Here, I'll just inflate this just a bit so you can see it better. So down when you right-click on a PC or whatever you do on a Mac to imitate right-clicking because you don't have a right mouse button, choose Add Trend Line, and it will automatically compute that. It'll do the calculus for you, and there's the trend line right there. So this is the trend line for the television size versus price. And then once you've got this, over on the right, you have several things that you can set. For example, display equation on chart is what you would want to do if you want to see the equation. So I'm going to click display equation on chart, trying to click it. I don't know why it's not selecting. Oh, it's because I was on the wrong screen. I'm clicking over here and it's like nothing's happening. Okay, display, there it is. Display equation on chart. Come on, there it is. And there it is. There's the equation. Let's get rid of this. So here's the equation. You can move it around. We can make it bigger if we want to. Maybe we can make it bigger. Yeah, there it is. It's nice and big so that you can see it better. So there's the linear regression equation that we can use to make our predictions. Okay, so I have here already set up just a few more things that I wanted to show you. Ooh, I don't want to show you that. Just a minute, I have to cancel this and this. Okay, let me pull this over here. There. So you might be wondering, what sort of homework are you going to have to do? Well, one of those homeworks is going to have to do with correlation. Oh, the mouse disappearing is so annoying. And so it says, which of these data sets could have a regression line with a negative y-intercept? So negative y-intercept just means that the y-intercept is below 0. So it's where that line crosses the y-axis. And so you can read and just think about, like, what do they mean by these things? Do your best with these sorts of questions. There will also be questions about, like, positive slope, negative slope. Those are like positive and negative correlations. So that's the first type of question. Let's see, where's my, darn it? Oh, there it is. But here's another one, and this is going to be extremely difficult for me with having no mouse showing up on the screen, but you can see what to do. Is we're going to want to draw the equation. This is one of these things that's due on Wednesday. So on Wednesday, before Wednesday, just do it today. It's easy. You'll want to graph that equation. Probably you know how to do this from your days in like basic algebra class. It's not all that hard. Okay, I'm trying to find, there it is, that dot. So we're going to move this down to 2. Because the y-intercept is 2 for that. Notice that it's 7x, the slope is 7, the y-intercept is 2. And then I just have to, let's see, if I go over 10, where's that? Oh, it went too far there. Oh, there it is. If I go over to 10, 10 times 7 is, oh, it's going to be too far. How about 5? 5 times 7 is 35, plus 2 is 37. So there it is. So you'll have questions like that. A couple more, or actually just one more to show you, I think. Yeah, this one. Yeah, this is one more to show you. And this is one, this is a little annoying to me because it's a little tedious, and I definitely can't do this without being able to see where my mouse is. But they give you some data, and you basically just have to move the points. Unfortunately, the points are labeled, which annoyed me when I did this earlier. So line 5, whatever these are, lines, I guess they're assembly lines, have, or whatever it is. So you change this one to match 70 and 30. So you'll have to move that dot. And so you're basically just making your own scatter plot. Whoops. Yeah, it's interesting. The mouse only shows up on, oh, there it is. There. Okay, so I'll move this down wherever it belongs. And so you'll move all of your dots and then submit. And that's all you have to do is move the dots. I think there's one or two other things. They do ask you to compute correlation, but just to review, we have 2 assignments. One is due Wednesday, one is due on Monday morning. You can do them both today, but do this one for sure today or tomorrow, and then you can save that one for Sunday if you want to. And I will get the stuff, this matched pairs thing. I'll put that up. Can't believe I forgot to put it up, but we'll get it straightened out. So I hope you have a blessed, wonderful Thanksgiving. We'll see you here, I guess, next Monday, a whole week from now.